The third method of smoothing data is known as deseasonalising data. And when we do that process, we use what we call a seasonal index. So that number, that seasonal indice, that number, it tells us how a particular season compares to an average season. The example given is sales data for a year. So there's 12 seasons there, 12 different seasonal indices. So you can see there that a seasonal index of 1.2 for February means that February unemployment figures are generally 20% higher than an average month. April, having a seasonal index of 1, means it's average. So April sales are average. Anything greater than 1 is above average sales, and anything less than 1 is below average sales. So when you're looking at the next one, seasonal index of 0.9 for July means in July that the unemployment figures are generally 10% lower than an average month. So anything less than 0.85 as a seasonal index means sales are generally 15% less than average. Anything higher than 1, for example, December sales, generally 10% higher than an average month. So we use a seasonal index when we're doing a deseasonalising on a set of data. The formula is given there. So a deseasonalised figure is just the actual figure divided by the seasonal index. Using algebra, if you were to rearrange that equation and figure out what the actual figure is on its own, it's basically just the deseasonalised figure multiplied by that seasonal index. So there's a couple of examples from the textbook for you to try there. And then when you flip the page, there's the ice cream example again. So going back to that same data that we've used both for mean smoothing and median smoothing, we're going to try deseasonalising this data as well and see which one is the best method for this particular data. So the first thing you need to do when you're deseasonalising data is to find an average. So we want to find the monthly average for that year. And to do that, obviously, we add the 12 sales figures and divide by 12. So when we do that, our seasonal average or our monthly average for that year in 2014 is $5,103.33. So we're going to use that seasonal average to work out the seasonal indices for each particular month. And the way we do that is to take the actual figures for January and divide by the seasonal average, which was 5,103.33. And when we do that, we get a seasonal index of 1.74. So basically that means if we're interpreting that, it means January sales are 74% above average monthly sales. And if we do the same thing for every month of the year, actual figure divided by seasonal average, we'll end up with a seasonal index for every month. And as you go through, as you do your calculations, you'll find that some are going to be above 1, some are going to be below 1. So as you do those, hopefully you'll get the same numbers as me. If you're looking at the June figure there, a seasonal index of 0.45 just means that the June sales figures are generally 55% below average monthly sales, which makes sense. So you go through all 12 and fill it in. Once you've done the calculations for all of those, you'd have to work all of those out. And if you see there, the December figures being 1.68 basically just means December sales figures for ice cream are generally 68% above average monthly sales. So pretty quick and easy to do the seasonal indices. Then to use the seasonal index for each particular month to find the deseasonalised figures. So again, straight out calculation, the actual figure for that month divided by the seasonal index for that month. And you'll end up with a deseasonalised sales figure then. So you would need to do that for every month. So again, when you get, as you're doing those, when you get to June, you'd be taking the average figure for June, the actual figure I should say, dividing by the seasonal index for June, and that would calculate to $5,111. So you can do all of those, the 12 deseasonalised figures. Once you get those 12 deseasonalised figures, you would then need to put them into your calculator. So you can see I've got a column there in my spreadsheet. First one's month, the second one is the ice cream sales, and the third one is the figures that I've just calculated there for the deseasonalised ice cream sales. So when you've got your deseasonalised figures, what you need to then do is to open up a data page, months on the bottom, ice cream on the vertical axis, and when you menu, plot properties and connect the data points, that gives you your time series plot, your original data, and then you're going to have a plot on the same axis. So menu, plot properties, add Y variable, and the Y variable is the deseasonalised ice cream sales. So you can see that's done a fantastic job of linearising that data. So what was looking almost like a parabola, the original time series plot, has now been linearised into pretty much a straight line right across the board. So all the seasonality has been removed, and you can see pretty much there's no trend. The ice cream sales for every single month of the year is pretty much the same. So that's really what we're looking for when we're trying to do a smoothing. We're trying to get it as flat as we possibly can. We then do a regression analysis on that straight line, and you can see there I now have a regression equation. So I need to write that equation into the booklet there on page 23 using the correct variables. So when you go onto your next page, obviously you'll be able to plot the two graphs on your screen. I don't need to do that on the screen, I hope. But you would need to then write your equation. So remembering that your Y variable is your deseasonalised ice cream sales is equal to 5113.33 minus 1.15 times the month. So as long as you've got your equation in the correct variables, you can then use your equation to forecast actual sales figures for months in the future. So the questions that would be similar to what you would be asked in this kind of question would be to predict sales figures for, say, January in 2017. So you can have a look back at your original data, and the first bit of data there for January was January 2014. So as you count through the months, you'd end up, you've got to add another 3 years on basically. So you've got month number 1 is January 2014 plus another 36 months. That's how we get to month number 37 when you're doing the forecasting. So for January 2017, month number 37, it's basically just using your formula for your equation that you've just calculated, minus 1.15 times by 37, month number 37. So your deseasonalised figure is $5,070.78. But that is not the actual figure, that's the deseasonalised figure. You want to find actual sales figure, so you then need to do one more calculation. So the actual sales figure is going to be what you calculated for your deseasonalised figure, multiplied by the seasonal index for January, which was 1.74. And that'll kind of correct it back to what it should have been in its actual form. And when you do that calculation, the actual sales figure for January in 2017 predicted is $8,823.